Hello beautiful people, it's Miss Beaching here. This video is going to be about different types of equations. So we've looked at linear equations in the last few skills, and in this skill we're going to look at two other types, quadratic equations and exponential equations. And we'll talk about the differences between the three. There's a big table here, I'm just going to go through it step by step and talk about each part. So as we discussed in 4.6, linear equations go up or down by the same amount every time. And you can see that in the example down here. In this pattern, each step goes up by 2 boxes or 2 squares each time. So every single time the pattern goes up by 1 step, the number of boxes increases by the same amount every time. That's a linear equation. And it's called linear because it makes a straight line when you graph it. Pretty straightforward. And the equations look something like this. So you've got, if it's y and x, you've got y equals, sometimes there's a coefficient here, something times x plus a number. Nothing too complicated. And just as an example with a number pattern, again, you can see in this pattern here that the pattern is going up by 3 every single time. It's going up by the same amount each step of the pattern. And as an example for a worded situation, if Nate has $5 and he saves 10 each week, the pattern's going up by 10 each time. That's not changing. It's 10 every single week. So that's a linear equation. We've already looked at those. The other two types of equations are a little bit more interesting and they're a little bit trickier to use. So quadratics are shaped like this, like a smiley face. Sometimes they can be upside down, like a sad face. But they've got that curve, and that curve's called a parabola. You don't need to know that, but fun bonus fact. So quadratics go up or down by a linearly increasing or decreasing amount every time. Now that's a lot of words. So let's actually look at what that kind of looks like in a pattern. So you can see in this pattern here, the amount that the number of boxes goes up by is increasing. Because in this first step, we're increasing by 5 boxes. In the next step, we're going up by 7 boxes. And in the next step, we're going up by 9 boxes. So then if you worked out the increase of the increase down here, you can see that the increase is increasing by 2 each time. So it's like a double layer on the linear. The increase is increasing by the same amount every time. And that's why we say it's linearly increasing, because like we said before, linear means the same amount each time. So the increase is increasing linearly. And it could also be decreasing linearly as well. That also counts as a quadratic. And we can see that in this number pattern, a similar thing is happening. So we're going from adding 6 to adding 10 to adding 14 to adding 18 in each step. And that increase is going up by 4 each time. So the increase is linearly increasing. And again, you could do this for a decrease as well. With the worded situation, we've got a similar one to our linear, but this time we've started with $5 and we save $10 on the first week. Each week after, they save $4 more than they did last week. So we started with 10, and then in the next week we save 14, so we end up with $24, and then next week we save 18, and so on and so forth. So it's increasing or decreasing by a linearly increasing or decreasing amount. So it's kind of like increaseception. You look 2 layers down to see that linear increase. And you might notice that if you compare the linear and the quadratic pattern goes up a lot quicker than the linear pattern does. Or it might go down a lot quicker than the linear does. Equation-wise, quadratics look a lot like this. So this is the simplest one you could possibly do. But the thing you got to look out for in a quadratic is this squared. So if you see a variable squared, and that's the highest power you see, it's going to be a quadratic. Some other quadratics might be more complicated. We're not going to look into them much today, but it could be something like 3x squared minus 2x plus 5. That is also a quadratic, but just a more complicated one. We're not going to deal too much with the equations yet, though, because you need to learn a lot more maths before you can deal with those effectively. But that's quadratics. Exponentials are pretty cool, and they're actually quite relevant at the moment if this is still 2020, because we're in the middle of a pandemic, and the rate of spread of a pandemic is actually exponential. So you can see with this graph, it goes up really quick. It can also go down really quick if you flip it upside down. So exponentials go up or down by an amount that multiplies by the same amount each time. So in the last two, we added an amount each time. This time, we're multiplying by an amount each time. So you can see why it would go up or down really quickly. And if we look in our examples, in this box situation, you can see how the number of boxes doubles each time. So it doesn't add by the same amount each time, it doubles each time. So you're multiplying the number of boxes by 2 each time you go up a step. And that's how it makes a difference from quadratic and linear. You're multiplying by a factor. Let's have a look at the number example. So in this example here, we went up by 6, and then we went up by 18, then we went up by 54, and then we went up by 162. And kind of like with the quadratic, you could see that there's a second layer here. But the difference is, in quadratics, you're adding the same amount each time. And in an exponential, we're multiplying by the same amount each time. So the increase is multiplying by a factor each time. And in this case, that factor is 3. So, and you can also see how, again, if we compare our quadratic and our exponential goes up much faster than our quadratic. And that's why pandemics spread so quick, because you're multiplying by that factor each time. In this last example, again, we're using the pocket money situation. So we start off with our $5, and we save $10 in the first week. Each week after, they save twice as much as they saved in the previous week. So in the first week, we're saving 10. In the second week, we're saving 20. In the third week, we're saving 30. So we're multiplying by 2 each time instead of adding 4 each time. In terms of equations, the main difference with an exponential is that the variable is the power this time. So you noticed in a quadratic how we had x squared. This time, in an exponential, we're doing a number to the power of x. So x is the power, and then the number's the base. And it doesn't always have to be 2, it could be 10, it could be 5, it just depends on what you're multiplying by each time. And again, like a quadratic, you can have more complicated versions of these equations, but we're not going to go into too much detail about that. So that's the difference between linear, quadratic, and exponential equations. In this skill, you're just going to be practicing identifying which type of equation it is. You're not going to be writing the equation, because that's a lot trickier. But you just need to use these ideas to help you identify, okay, is this pattern linear, quadratic, or exponential? Hopefully that helps you, and I'll see you guys next time. Bye!